Hi, my name is Drew Klein. Today I'm going to be presenting on the organolithium compound. So basically what this is it's just a simple molecule. It's a lithium metal that is bonded to an ethyl group, or any other R group for that matter. It can be a methyl group, it can be a phenol, it can be a benzene, anything with carbons to make it an organic compound. So I chose lithium as my metal. Here is just a simple drawing of the structure. It's just the lithium ion, and then it's attached at the lithium is acted as the R group, and it is onto the ethyl group right here. So a little bit about the history and the origin of organolithium. Wilhelm Schlenk. He was the first to actually synthesize the metallic compound, and he found out that it was a highly dangerous compound when they were put together. And he actually stated in his journal that methyl lithium ignites in air and burns to a luminous red flame in a golden color shower of sparks. So I thought that was kind of a very cool description of like how the molecule will react with just something as simple as air. And as below, this is the equation that he made up to show his findings, and it just basically shows that the transmetallation of the dimethyl mercury with a lithium metal. Okay, next about the physical and the chemical properties of lithium. Lithium is the third element on the periodic table, so that means it's one of the lightest solids elements. Before the two elements, it comes hydrogen and helium, so it's really not a solid. Those aren't really solid elements. So lithium is really the first solid element, and it's one of the lightest ones. It's even lighter than some liquids, but when it is exposed to water, it's very, very reactive, and it can be very, 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 very violent. Even though lithium has a low density, it is harder than any alkali metal, which means that it has a higher boiling point and a melting point. Lithium has a higher ionization potential and ionization energy, but lithium and organolithium have very similar reactions with water, which they can be very violent, and as shown in below, I guess that's what Schlenk was seeing in his observation, was the golden glow of the shower and the sparks. Next we have there's basically the reactions. So basically what do you do with the reactions of it? You just have your R group attached to a lithium, and then you use, to a metal, and then you use lithium, but you have to use two of them because it's such a light metal, and it only has 3 electrons, and it only has 1 electron to give away per element, or per molecule. So it's going to need 2 of the lithium molecules because it can only spare 1 electron. So basically, to make bromide happy, the lithium is going to give bromide 2 electrons, which is going to detach it from the R group, which could be the ethyl or the methyl group. Next we have the applications. So it is a very highly sensitive compound, as stated before. So there's not very many applications as far as like with using it like in the air and the water and stuff. I really couldn't find much of like how this compound could be used. And down here I just found another picture of what simply Schlenk was seeing with his observations of when organolithium was exposed to air or water, which is the bright luminous red glow of the reaction. And then these are just my resources that I used to find them. I used this the 200 years of lithium and 100 years of organic lithium chemistry. That was a very, very helpful source in this project. And that concludes my individual project too. Thank you.